Today is December 7th, 2011. We're on lesson 6.4, okay? So we're investigating sinusoidal functions. That's what our objective is here. We have two formulas: how to find the amplitude of a sinusoidal function and the equation of the axis, okay? We have Ferris wheel A, and a Ferris wheel, if you guys remember, is a circular object, okay? Should really define that, I guess, for you guys in case you don't know. A Ferris wheel is essentially a giant wheel. It's circular. Okay. Explaining the name. And the Ferris wheel will spin around. So normally you get on at the bottom of a Ferris wheel. Maybe you get in at the mid, depending where you are. Get on at the middle of the wheel. Maybe they have a ladder up to the middle. Who knows how your Ferris wheel is going to work? And it'll go around for a certain amount of time. That's the idea of a Ferris wheel, okay? Now what they've done is they've mapped the height of a specific chair on a Ferris wheel over time, okay? So our time here is our x-axis, and it's measured in seconds. Our x is measured in in seconds. Our y-axis is measured in height, meters, okay? So we have the Ferris wheel mapped out. Now this is just the first Ferris wheel. We're going to draw another one a little after. Our Ferris wheel A. The question's asking us, an amusement park, a math teacher had different students ride two Ferris wheels. Thomas rode Ferris wheel A, Ryan rode Ferris wheel B, which we'll get to after. A teacher collected the data and produced two graphs. Okay. Now in the first example, what they wanted to do is we need to first figure out what our peaks and our troughs are. So, in terms of an equation, where are the peaks of this graph? How many of them are there? 3. And they're all at 13. Good. So, we go through the number 13, which means the peak is when y equals 13. Okay? So, if we write it down here, our peak, y equals 13. We're going to do the same idea with the trough. How many troughs do we have in this one?
4, 2, 3.
We do get down here, it looks like 3 times. Okay? And how high off the ground is the trough? Yeah, we're at 1 here. So our trough would be y equals the value of 1. So essentially what we're doing is writing the equation of a line that's horizontal. So y equals 1. So we have 2 lines. We have a top and a bottom of this Ferris wheel. And what we're going to need to do is we also want to figure out what the period of this Ferris wheel is. Now remember, this is the tough part you guys had before. Now in order to figure out a period, I technically don't have to start from where they started. I can pick any point along this graph and find the period from there. So in fact, you know what I'm going to do? I'm going to try from here. Our point of 40, and we're going to go through this, okay? Now, let's highlight our period. It heads up, comes back down. Now, I'm back at, where did I start for our first point? Looks like about 7. So I started at 40 and 7. So it's important that we remember that point on this graph. Now, is that a complete period? Because I'm back at 7 now.
No.
Why is it not a complete period?
Because it's 7 on the way down.
That's right. So when we were at our 7 before, technically our graph was heading upwards. We've come back to 7, but we're not getting there in the same way. So we're not finished our period. We have to continue down, come back up, and now we're at 7 again. Is this a complete period?
Yes.
Okay, so here's our end of our period, which is at 80 and 7 again. So in order to figure out how long a period lasts, I'm going to take my 2 x-axes, my 2 x points, and I'm going to subtract them. How long did a period last? 40 seconds. Pretty easy to look at. We take our 80, subtract 40. 1 period is 40 seconds. Okay? So we could probably break this up. Our first one started at 0. We know that it completed a period after 40 seconds. Then from 40, we went to 80. That's how we discovered our period. And then the next period would actually end at about 120, which would probably be here. Now, it looks like the Ferris wheel didn't run that long. It stopped at a point before that. Okay? So, we figured out quite a few things. The peak is at y equals 13. Trough is y equals 1. The period is equal to 40 seconds. We've solved that. So in other words, remember, we're talking about a Ferris wheel. In order for this wheel to get all the way around, it's going to take it 40 seconds. Okay? So it takes 40 seconds for this to go all the way around, which means I could probably break it up into points. That's right. If I broke it into quarters here. All right? Now, they didn't ask us to do this, but I want to see if I have the logic. Because let's say I did start at the bottom. How long will it take me to go a quarter of the way if it takes 40 seconds to come all the way around? Yeah? This would be at the 10-second mark, 20 seconds, 30 seconds, and then back at 40 again where we started. So we're just trying to gather as much information as we can right now about this. Another thing we probably want to figure out is the equation of the axis. Okay? Now the equation of the axis, we have our formula over here. So we're going to pull it in and solve. We have our equation of the axis, which is our peak plus our trough divided by 2. So we're going to take our peak value, which is 13, and I'm going to call this EOA from now on. Our peak was at 13. Our trough was at 1. So we add the two together and divide by 2. We end up with 14 divided by 2. The equation of the axis passes through what? 7. So the actual equation would be y equals 7, just like we did equations for our peaks and our troughs. The equation of the axis is at 7, which makes perfect sense because that would be the exact middle of the Ferris wheel. Okay?
Look at it.
Yeah, you could probably look at it and see it right from there. But if you get a question where there's no diagram and you're unable to draw the diagram, you'll need to know this using the numbers. Exactly. Okay. So we figured out the equation of the axis. That's good. We've broken this up into quite a few quadrants here. The next thing I want us to solve is the amplitude of this. So how high and low does it go? Okay. Okay, so in order to find the amplitude, it's a very similar equation. But the important part here is we are subtracting when finding the amplitude. We're not adding. So our peak from the other page was 13, and our trough was 1. We're dividing by 2, which is going to give us a 12 divided by 2. Oops. 6. Okay? Now, what that means is that's the distance from the middle, or the equation of the axis, to the highest and lowest point. So we go up 6 and we go down 6. So if we go and look at this graph here on the other page, from the middle, the equation of the axis, up to here, our peak, is 6 centimeters, which makes sense. 13 subtract 7 is 6. And from the equation of the axis to our trough is another 6 meters. Okay, so we've come up with quite a bit of information. I'm going to write it all together on the other page so that we have it. Just 6. Okay. Our peak was 13. So, peak in our trough we have the equation of the axis, so EOA, we knew was y equals 7. Our amplitude was equal to 6. Our period was 40 seconds. So, I got quite a bit of information here. What I'm going to do is I'm actually going to try to draw this Ferris wheel and plot out all the points like we had kind of did on the other page. Draw it out like a wheel. Yeah, as a Ferris wheel. Okay? So, here's our Ferris wheel. It's above the ground. Okay? Now, looking at our graph on the other page, because we do want to start, if you guys notice, apparently you get on this Ferris wheel at 7 meters high. So there must be some kind of ladder to climb up to it, because we know the lowest point of the Ferris wheel is 1 meter above the ground, and the highest point is 13 meters. So maybe there's stairs, okay? Stairs or a ladder. Well, we assume it's meters above the ground. So we'll say there's some kind of stairwell, and it goes up to 7 meters, okay? The equation of the axis was 7 meters, so the middle of this Ferris wheel was 7 meters above the ground. So that's the entire distance here, is 7 meters. The distance above the ground is only 1 meter, because the lowest point of the Ferris wheel was at 1. Okay? I know that's not quite the scale. The radius of this Ferris wheel is 6 meters, because we know from the middle to the bottom, or from the middle, I didn't draw that very nice. We know that there's 6 meter radius. We also know that it starts here, because this is where we get on, which is 7 meters. So as it goes around, you're going to be at your highest point 10 seconds in. 20 seconds in, you're going to be level again with 7. At 30 seconds, you'll be at the lowest point. And then again at 40, you reach that. So let's say this Ferris wheel had 3 or 4 cycles. At 10 seconds, we reach the top height. Again, at 50 seconds, we reach the top height. Remember, a period is 40. So it's going to take 40 seconds to complete everything again. So we went 0, 10, 20, 30, 40, 50, 60, 70, 80, we'll say 90, 100. And when we set this Ferris wheel, if you remember, look, it said it ended after 110 seconds. Now, I know it's not exactly the same as your book. That's the way I drew it on this page. It ended down here at 110 seconds, this Ferris wheel. So, which makes sense. Maybe they want you to get off when you're only 1 meter above the ground in this question. Stairs are only for getting on? Oh, is this the right one?
That's ridiculous.
Where is it? There it is. Sorry.
It's all right.
So, apparently the stairs were only for getting on, and then at 110 seconds, the Ferris wheel would stop, and you would get off the Ferris wheel there. Okay, so they're going to ask us for the circumference of this circle, okay?
Pi squared.
Yep, circumference is 2 pi r, or c equals diameter times pi. So you either multiply the radius by 2 and get the diameter, or you just find what the diameter of the circle is and times it by pi. Okay? So in this one, the radius of the circle is 6. So we get 2 pi times 6. 2 times 6 is 12. Okay? And you're going to see it's the same thing here. The diameter is the entire distance, would be 6 plus 6. So we have 12 pi. So we have 12 multiplied by pi equals 37.69. We're going to say 37, or, yeah, we'll say 37.7. Okay, so we found the circumference, which means from one end all the way around to the other end is 37, I think it's in meters, 37 meters distance. Now, here is how we find the speed. To find the speed of this object, we have to figure out how far it is all the way around, which we just did. So distance divided by time. Okay, you guys probably would have done something like this in science. Speed those little triangles they made. Our distance is 37.7. the amount of time it takes to cover that distance. Anyone
40
remember?
seconds.
40 seconds. Wait, so we didn't do pi r squared.
It equals the same thing.
37.7 divided by 40. So, 0.94.
Is that miles?
So what they're saying here is that this Ferris wheel covers 0.94 meters every second. Okay? So it's almost traveling a meter a second, this Ferris wheel.
That's bad.
So it's only up until the point when you started to use pi.
Okay. Okay, Ferris wheel B, which we have to figure out. Ferris wheel B. We're going to quickly go through this. We take a look at our peak. It reaches y is equal to 7 in this one. A lot different from our other Ferris wheel. The trough or the lowest point is at 1 again. From looking at it, can you tell me where the equation of the axis is? What is it? 4. Good. Equation of the axis goes right through the middle. Okay. Now, we can prove the equation of the axis with our equation. We said it was at 4. We're going to prove it. Our peak is 7. And our trough is 1. We add the 2 together and divide by 2. 8 divided by 2. Equation of the axis is y equals 4. We got it. Amplitude. Same formula except we subtract the 2. That's going to give us 6 divided by 2. Amplitude of 3, which makes sense. From the equation of the axis up is 3 meters. And from the equation of the axis down is another 3 meters. We got to find the period of this function. It starts at 4. It comes back to 4 after 20 seconds, but not in the same way. Goes down and comes up again. Our period lasts 40 seconds in this question, same as the other one we had just done before. So it turns out this one goes through 2 cycles. This one ends at 80. Okay, so we go through 2 cycles. We have our period, amplitude, equation of the axis, peak and trough. We have all that information. We're going to write them down here. Peak is y equals 7. Trough, y equals 1. Equation of the axis, y equals 4. Amplitude is equal to 3. Period is 40 seconds. Okay? Now, they want us to find the circumference of this one also. Circumference of this, we're going to use our 2r pi. We know that the radius is actually equal to the amplitude. So we have 2 times 3 times pi, which will give us 6 pi. And when we go to solve that in this question, 6 times pi, 18.8. 18.8 meters is the circumference of this. We also know that they want us to find the speed of the second Ferris wheel. The speed is going to be equal to the distance divided by the time. Now, to complete an entire rotation, it covers a distance of 18.8 meters, but it also takes it 40 seconds to cover this distance. So our speed will be 18.8 divided by 40, 0.47. That will be in meters because our top one is in meters per second. So this is much slower than the other Ferris wheel we were dealing with, A, and this is Ferris wheel B. Amplitude will be the same as your radius.